Welcome back, everybody, for another video. So, in this video, what we're going to be going over is we're going to be discussing broaching the hex in the speed handle hub. So, without further ado, let's go ahead and get started. So, what I want to do here is I actually created a 3D model in Inventor of essentially what your piece of material is going to look like. Now, this is essentially what you have after turning up. Plus, if I subtract this, went too far. So that's what you have after the turning up, roughly speaking. Your hole may be a little bigger, but that's about the only thing that would be different here. What you're going to do first is you're going to rough that hex in there. And this is simulating it being roughed with a 1/2 inch end mill in this case. So that's basically what you're going to end up with. Now, what I want to focus on here is the pattern that we're going to use to broach this. We are going to be using, we're not going to walk our broach around it. We're actually going to use our C-axis in the 5-axis machines to rotate whatever degrees we need to repeat and keep recutting sides. So I'm going to kind of demonstrate that here by kind of toggling through some operations that I made up. To start off with, what I want to do is, first off, the first things that we really need to figure this stuff out is we need to know what the size of our hex is, and we also need to know what the size of our broach is. So I actually have both of them that I kind of drew up in sketches, and you can see here, if you look at your print, it's 760, I think, is plus, I think it's 760 plus or minus, I think it's plus 5 minus 0. So basically what I did was I said, okay, the finish, we'll shoot for like 0.762. And then the size of your broach is 11/16. So that's basically the size of your broach, which is 0.688. Now, what we're going to do is we're going to take this broach, which is our inner hex, and we're going to start in the very center. And we're going to broach down. We're going to just basically push that thing right through this roughed out hole. And again, this was roughed out with a 1/2 inch end mill. So that's, if you go down through the middle, that's all the material you're going to be cutting out, just a little bit on those corners. So we're going to broach down through the center, and then we're going to walk this thing over to the right. So if we look at that, we just basically got to figure out, number one, how much can we take off with a broach? Well, the answer to that, it depends on if it's full engagement or not. Well, we're not really fully engaging here, but at some point we will be fully engaging once we get all the way over here. Basically, that whole edge will be cutting. So we got to kind of be careful. We don't want to take off too much. So in this case, I would say anywhere up to like 8 thousandths, maybe. But I would probably go less than that. So maybe around 5 thousandths to 6 thousandths, somewhere around there. So what I want to do is I want to figure out how far I have to go over. Well, that's pretty easy math. And we're just going to take that 762. We're going to subtract our 688. We're going to divide it by 2. And that's going to tell us the distance from here to here. Okay? That distance happens to be 37 thousandths. Well, if I take 37 thousandths and I divide it by, let's just say 8, I should get, I don't know, somewhere around like 4. I better do it. It should be less. It should be less than 5 thousandths, essentially, is what I'm getting at. Because 40 thousandths divided by 8 would be 5 thousandths. So it should be slightly less than 5 thousandths. All right, so that'll tell me what my step over is. And I'm under that 6 thousandths max that I just said for this, because we're going to have that full engagement. So that'll work for me. So I have to figure out, basically I figured out how many steps I want to take, and then I'm going to step over that amount. So basically what I did was found out the distance from here to here. And I said, okay, the most I want to take is about 5 or 6. I know that 40 thousandths divided by 40 thousandths divided by 5 is 8. So that basically means I have about 8 step overs. And then I would divide that 40 thousandths by 8. And that would give me the exact number I need to step over. Okay, so that's how you figure out your step over. Now that we went over that, I'm going to kind of show you how the pattern goes here. So I'm going to turn these off. Actually, I'm going to turn the first one off. So I'm going to leave our finished sized hex so you can kind of see this progressing. So as I move it down, all right, so right there, that's our first hex. So it's going to cut out that one. That's our first shot. The next one takes a pass, moves over that step over amount. So whatever we determined that 4 and some tenths or whatever it is, takes another step, moves over that much, takes another step, moves over that much, takes another step, moves over that much, takes another one, and you can see my passes here. I chose to take 8 passes. So, and now I'm finishing at that final size. Okay? So, if we're moving over the same amount each time, what that tells us is we can use a sub-program with a G91 and just keep repeating that process. Likewise, while we're here, we might as well step up and clean this corner out. So for this, obviously what I'm going to need to do is I'm going to need to calculate the side of my broach, the difference between the side of my broach, the length on one side of my broach, and the length on one side of my finished hex. So again, subtract them, divide by 2, and that's how much you need to step up total. Now, since we're going to be taking off a little bit less going up, we could probably take off about somewhere around 8 to 10 thousandths at a pass here. So what I'm going to do is turn this off again, visibility, and we're going to go through our step ups. So here I'm stepping up. So what I chose to do was 3 passes. So whatever that amount equaled out to, I broke it down to 3 passes. So that step over, that step up in the Y, it would basically be that amount divided by 3, and that's going to give me how much I step up each time. And then finally, the last pass, and there, now I've cleaned this out. Okay. Now, when we go to do the other side, we're not going to just walk it over. We're going to rotate our C-axis. So we haven't rotated our C-axis yet. We've just walked it over, walked it up in position. Now we're going to rotate our C-axis. We're going to take this side, and we're going to bring it over here so that it's at what we would call 0, essentially, rotational 0. So I'm going to hit OK. And let me just kind of rotate this to get it close. And I'm going to hit look at. Uh-oh. Got to have that active before I do that. Right there. Okay. So we would have just executed a rotation to make this side here at rotational 0. Now that we've done that, we'll talk about the codes for that. That's going to be using your G254 with a C-axis command. But we'll talk about the code here in a minute. I just want to go over the pattern that you're using at the moment. Okay, so now we don't have to step over anymore. We don't have to step over to here. It's already cleared out for us. So all we need to do is do our step up. So we don't have to repeat that X position. All we need to do is repeat our Y step up. So step up 1, step up 2, step up 3. And of course, that's the same program that we already wrote for the first one. So now we can just recall that subprogram. Likewise, rotate this. If I don't get it close, it'll align at the Y. There we go. Okay, so now we rotated with our G254 again and re-zeroed. Pass 1, pass 2, pass 3. I think you get the point. Basically, you're going to rotate as many times as you need to clean up all these sides. When you get down to essentially the last side, you're going to have this little chunk in here. And let me rotate it around so you can see it correctly. Okay, so you'd have it, this would be basically your last time that you're going to run your subprogram. Cuts it out, cuts a little more out, and cuts the final amount. So that's essentially how you're going to do this, at least from a cut pattern perspective. Now, when you're programming it, you're going to need to create several programs, sub-programs. Now, I have not put a lot of the numbers in here because they're kind of up to you, or you need to figure them out. I don't want to write this program for you per se, even though I'm giving you a pretty decent template here. So just calling our tool, our 11/16 broach, pre-calling the next tool, whatever that's going to be. M19 is crucial. So M19 is going to be your spindle orientation. That orients your spindle. Now, if you just call an M19 without anything else after it, it will rotate to basically spindle orientation 0. And that's where it aligns itself to do a tool change. But if you have the spindle orient option, which we do on our VF4s, then what you can do is you can actually add an R value. The R value will allow you to rotate to a specific degree. So in this case, I just made up a degree, 29.6. To find that, what you're going to have to do is you're going to have to call up an M19, see essentially where the hex is relative to the M19. So generally, I put the broach, which looks like this. So it's just a hex broach, not very long. Needs sticking out a good bit. I tend to put this in a solid holder if I can, because I have a set screw flat kind of ground on this. That way it can't push up in the spindle. If you put it in a regular collet, it can slide up. It probably won't. Worst comes to worst, you probably put it in a regular collet. But just in case, we have a flat ground on this. So anyway, when this is in the spindle and you put M19 in, this is going to orient a certain way. It's going to lock the spindle like that. It's going to hold it in place. And when you look at it, what you really want is you want that hex, this edge of that hex, to match or be aligned to your x-axis, or essentially your x-axis to be perpendicular to that surface. So it should be perpendicular to that surface. To do that, what you need to do is, usually what I do is put it in, I'll call up M19, and it'll orient. And if it's way off, I'll put in maybe, I don't know, like 10 degrees, and I'll see if I got it closer. If I got it closer, I'll put in 12 degrees, and I'll just keep putting in degrees until I get it eyed up, so it looks like it's basically parallel with the y-axis, perpendicular to the x-axis. Once I got it pretty close, I'm going to put an indicator on there, and I'm going to indicate along it. So I will keep hitting M19, and I'll keep adjusting that number even to a decimal point until it reads pretty much 0 all the way across there. Once I have that reading, that will repeat. The only way that wouldn't repeat is if you take the tool holder around out and you rotate it 180, which you can do because the drive dogs, or if you take the tool out. But otherwise, that should continuously repeat. Shouldn't have any issues with that unless your tool's loose and it somehow moves in there. But otherwise, it should repeat. So once you've found that rotational number to get this basically parallel with the y-axis, perpendicular with the x-axis, or the side, the flat on this, like that. Once you figured out that number, you could just put that number into your program. So you'll have to figure out that number by indicating it, as going through the process that I just said. Next thing you're going to do, obviously, you're not going to turn the spindle on. Normally we turn the spindle on. Not doing that here. So next thing we want to do is we want to go to our location. So we're going to go to our X, Y, 0, which is going to be center of our part. We're going to go to C0 because we should have indicated our vise. C0 should be aligned. There's no other aligning features on this part yet. This is going to be the first one that we put on it. So C0, or if you have other ops before this, if this is not your first op, if you chose to do the drilled holes, the drilled tapped holes, and the counter bores around the outside, maybe this C value will be some multiple of 360 because you will have already gone around the part. It may have, the C axis may have wound up to 720 or something like that. You may have to make this a multiple of 360 so it doesn't unwind the whole way. It would just be a little bit more efficient. But if you choose to make this the beginning, you could just start at C0. Obviously, A0 is going to be right. You're going to want it straight up and down. You don't want your trunnion tilted down. G43, normal codes. We're going to wrap it down to 0.1 above the part. Right here, we're calling our first subprogram. Okay? So M100, or sorry, P100 is going to go down to N100. Obviously, all your subprograms will be at the end of the program. So this program, or this subprogram, now that we've positioned ourselves at X, Y, C, A, 0, 1 inch above the part, we are going to call up G0, G90, 254. Now, we are already at 254, so this really isn't going to do anything for this. It shouldn't move. This will come in handy later on, but we do want this active. So we're going to call 254 X0, Y0. That's going to ensure, regardless of how that thing's rotated, it's in the center of that part. So call that up. We're going to wrap it down to 0.1 above the part now. And you might realize that some of these are redundant, so I just put these H values in here. They're redundant, but I like them in there with the G43. So we're 0.1 above the part, center of the part. Then we're going to call up another subprogram. So we're going to call up a program with a number of repeats needed based on our X step over amount. So how much ever we're stepping over, how many ever times we need to do that to end up at our final X location for that edge. In other words, to get to here, to get to the edge of our broach to this edge, whatever that is, and we know that that's going to be your finish minus your broach diameter divided by 2, right? It's going to be positive X, that amount. But that will be based off the step over amount you choose. So how many times you need to repeat it to get that, that's what your L value is going to be. Now let's go down to P55, or N55, I guess. N55, okay? Once again, I am reactivating this M19 before I take a pass. The reason I am doing that is because that will time out. M19 times out after a certain amount of time, so I want to keep reactivating that before I take every pass. That way, it wouldn't have alarmed, or it wouldn't have timed out yet. So it would have taken my first pass fine. But once it gets to like the 5th or 6th pass, it may have timed out, and then the broach will start walking or turning while it's going through, and it'll just be a disaster. So make sure you're reactivating that right before you take the pass every time. So I always put that in my sub program. And remember, this number is not the number you're going to use. You're going to need to figure it out for yourself. Okay, so I'm taking that first pass at 0, 0, right? I haven't gone anywhere yet. I'm going to take that first pass. G91. Oh, sorry. Whoops, wrong one. Sorry. G1, Z negative, and then the minimum distance you need to broach through the part. So don't go way through, because you do not have a lot of length on this broach. You could just barely make it through. So the minimal distance you need to completely clean out that surface all the way to the bottom, that's all you want to go. Then we're going to wrap it up. By the way, feeding it 120, so you can feed this pretty fast. Just goes down, shears it. Z.1, wrapping back up. And then I'm going into a G91, and I'm stepping over my X amount. So whatever that step over I determined based off of my number of repeats, they should be, the math should work out for those. That's what I'm going to have in here. I'm going to step over that amount. Go back into G90, M99, goes back up here, and I have that repeat amount in here. So I'm going to repeat that. It's going to come down, do it again. Now it's stepped over that amount. It's going to take another pass. And if I have my L value correct and I have my step over correct, if they are proportional, or they are the right relative to each other, this should work out. Okay? So we'll assume that what we've done to this point is that. Oh, not that. No. Yeah, that. Sorry, I'm misaligned here. Let's do this. There we go. We'll assume that that is what we should have ended up with. So we'll assume everything worked out, and we ended up with that exactly right there. Okay, so we've exhausted that L number there. This L number up here. We've done that amount of repeats. Okay, comes down. It's going to broach it one more time. Because remember, we did one in the center. We didn't move over at all. So it's going to do that last pass. This would actually be our finish pass. So after this, I should say it would look like this. We would have had some material right after the M97 P55. Okay, so now it should look like that. Next, we're going to do our step-ups. So we have another sub-program for that. Calling up M97 P56. Number of repeats needed based on the Y step-up amount. Okay, so go down to P56, or N56, I should say. Down here, I am reactivating my M19 once again. Must reactivate that or you're going to end up with problems, I promise you. G0, G91, and then my Y step-up amount. So I'm going to step up. G1, G90, Z minimum distance to get through the part. It's going to be the same number you're using up here. It's going to come down, broach through it, wrap it up to 0.1, end the sub-program, come back up here, and it's going to repeat the number of times that you tell it to repeat. Again, that number should match your Y step-up. Not match your Y step-up, but it should coincide with it. So the amount that you need to get to that corner, in other words, from where it's at right now, get that broach corner up into the finish corner, that amount should be the step over times the number of repeats, essentially. Okay, so once that's repeated all those times, we're going to end up like this. All right, and now it's going to come down. After it finishes that, we're going to go G54, G0, G91, C, and we're going to rotate the C axis, the amount of degrees we need to orient the part like this. So our x-axis was passing perpendicular, passing through this side. Now it's passing through this side. So you have to figure out how many degrees between here and here. It's pretty easy math. But I'm not going to give it to you. So you're going to rotate. It's in incremental. So you're going to rotate that amount. G90, M99. So now we're coming back all the way up to our main program. We immediately go into another sub-program with a number of additional sides to be broached. We'll come back to this L value. All right, so we've rotated. Our part looks exactly like this right now if we're the spindle, if we're the broach. We're looking at this from the point of the broach. It would look exactly like this. It's even oriented correctly. So now we need to go down to P101. P101, G0, G90, G254. Now this rotated. It is going to be off-center in your vise. So once it rotates, it's not going to be in the same location. This 254 X final location, we'll talk about that. Let's just for a moment say that this was X0, Y0. If I call 254 X0, Y0, after I rotate it, it will put my broach directly in the center of my part again. So it knows where that's at based off of the center of rotation for my rotary axis and my trunnion. So that's how you locate this each time with that 254. Now, we do not want to start at X0 because all this is already gone. All this material to X is already gone. So we want to start at wherever we finished on our last side. So if that was positive X positive 50 thousandths to get to this side, then that's the number we want in there. If it was X positive 90 thousandths, that's where we need to start at in this case. I can tell you right now, it's not those numbers. So make sure you don't put those numbers in there. You'll have to figure this out. You should know it because it should be the last place you end up after you do the X number of repeats here. It should be the difference between your broach and the finished size divided by 2. Okay, so I won't harp on that anymore. Moving on. So G41, we're coming down to 0.1. If we're not already there, it might be redundant, but we're just coming down. And then we're going to go into another subprogram, and it's going to be the same subprogram that we just went through. It's going to be our Y step up. It's the same thing. We're doing the same exact thing. So we already know what that does, right? It's going to step up, and we're going to end up with that. So as soon as this number of repeats finishes, that is going to be our end result. Okay? After that's done, G54, G0, G91, C, here's that rotation again, that C-axis rotation. It's going to be the same number that you rotated last time. So it's going to rotate that amount from where it's at. The reason we're doing G91, so we can keep repeating that. G90, M99. Okay, comes back all the way up to the top. Has a repeat. It's how many more sides we need to do. So it'll just keep doing that. So hopefully this L value isn't more than 6, because you only have 6 sides in a hexagon. But if you think about it, we did 1 before we ever even started this. So you kind of figure out how many sides you need to do. So just think about that. Once it's finished, it'll run this how many ever repeated times. Well, I guess both of these technically it will run. How many ever times it needs to, or you tell it to here with this L value. Then we have an M9, M5, and of course we probably want to send this up. I didn't put everything completely here, but we probably want like a G53, Z0, all that good stuff, and finish up our path. So hopefully that gives you some insight on how to program this. Obviously, if you have questions, you can come see me, but I think this video will help a lot rather than just doing it in class and not having any other resources, for you to kind of figure this out. So hopefully this was helpful. It took me a lot of time to create that solid model to do that. Anyway, if you have questions, let me know. Good luck.